This is the brief on the principles of cyclotron acceleration. So how do you get tiny charged particles moving crazy fast? Fast enough for things like cancer therapy or atom smashing? We're going to look at the genius of the cyclotron. It's a particle accelerator that pulls off this brilliant, synchronized dance between magnetic steering and electric kicks. First, let's talk about the magnetic field. Think of it as the machine's navigator. Its job is purely about geometry. It provides a constant inward force that bends the particle's path into a circle. But what's crucial here is that the magnetic field never actually speeds the particle up. Nope, it only steers. Second, so where does the acceleration come from? Well, that's the job of an alternating electric field. It delivers a powerful, synchronized kick to the particle, twice per revolution. And every time the particle gets that energy boost and moves faster, its orbit has to get bigger. That's what creates that classic outward spiral. Finally, the real masterstroke here is synchronization. You'd think that as the particle moves faster, along a longer path, it would take more time per loop, right? But it doesn't. The time to complete each half-turn stays perfectly constant. And that reliable timing is exactly what lets the electric field stay perfectly aligned to deliver those kicks again and again. The cyclotron brilliantly uses constant magnetic geometry and perfect time synchronization to efficiently accelerate charged particles.